In number 54, we're asked to find all zeros of the function. This is an application of the sum of cubes formula that we just did in number 52. I'd like to rewrite the formula. Remember, it was a to the third plus b to the third is equal to a plus b times a squared minus ab plus b squared. We're going to rewrite x to the third plus 1,000 as a sum of two cubes. That would be x to the third plus 10 to the third equals x plus 10 times x squared minus 10x plus 10 squared, or 100. Notice this gives us our first x value because we have a factor here of x plus 10, which means that one of our zeros is negative 10. All we have to do is set x plus 10 equal to 0, and we solve x equals negative 10. To find the other two zeros, we can take this quadratic and use the quadratic formula to solve. Remember, the quadratic formula will be given to you in your exam review packet and on your final exam. The equation is x equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. Substituting a equals 1, b equals negative 10, and c equals 100, the formula looks like this. X equals the opposite of negative 10 is positive 10 plus or minus the square root of negative 10 squared minus 4 times 1 times 100, all over 2 times 1, which is 2. Simplifying, we get 10 plus or minus the square root of 100 minus 400, all over 2. This is 10 plus or minus the square root of negative 300, all over 2. We are required to take out the square root of negative 1 as I and write 10 plus or minus I square root of 300 over 2. This would be an acceptable final answer for the other two x values. However, we all know that this could be further reduced. To further simplify, I'll rewrite the square root of 300 as 3 times 100, because 100 is a perfect square. 10 plus or minus square root of 100 is 10, and we can take that out as 10i square root of 3 all over 2, which then allows us to divide out a common factor of 2, and we get 5 plus or minus 5i 5 plus or minus 5i square root of 3. Our answers, our three zeros, are x equals negative 10, and instead of this we could write 5 plus or minus 5i square root of 3. Either one of these answers would be acceptable.